Well, hello, everybody. All right. It's been a super long time since I've done any kind of TidalCycle streaming, and I've been pretty active with it, but just haven't really shared anything. So anyway, I thought today I'd show a few things that I've picked up recently around ways to make sequences very, very, very quickly, just complex rhythmic stuff that's not necessarily random. Specifically, oh my goodness, I can't type. A function called binary, a function called binaryN, another one called ascii, and these all have to do with the struct function. And then also the at syntax. That's what I'm going to talk about today. Yeah. So hope everybody's doing okay out there. If the audio levels are not quite right, just let me know in the chat and I can fix that stuff up. So yeah, so binaryN and ascii, we'll start with that. So how's this level? Good old BD. So what you can do with Tidal is if you want to quickly create, or if you want to kind of define your rhythmic structure separately from your sound, you can use a function called struct. And it takes a pattern of ones and zeros or T's and F's. T for true, F for false, and 1 and 0, same thing. So if you do 1, this will play a BD sample once per cycle, like this. If I do 1 times 2, and so on. And you can use any of the TidalCycles mini notation in the struct syntax. So I could do a Euclidean sequencing here if I want. And so on. And if you do zeros, it will not, that's like an empty event where it won't play. So now I'm dividing the cycle into 4 pieces and I'm playing it on the first quarter and the third quarter. So you can arrange this however you want with ones and zeros. And this also works with T's and F's. It's the exact same thing, except it's true and false. So whatever your preference is, you can do either. Okay, so that's like the basic stuff. You can, so where the binary thing comes in is you can use this function called binary and then give it a number, just like an integer. And if I just eval this, well, hopefully you can see on the side here. So in my output window, make sure you can see that. Yeah, you can. So what this function is doing, if I just eval this number 234, it will take that and divide it, create an 8-digit binary number of ones and zeros. And we can see that for the first eighth of the cycle, it's a 1, second eighth, it's a 1, third eighth, it's a 1, the fourth eighth, it's a false, and so on. So we're basically getting a pattern that's equivalent to 1, 1, 1, 0, 1, 0, 1, 0. So binary 234 will generate an 8-step sequence with this form. So how we can use that is then as simple as this. And you can hear that rhythm in this representation. So you can hear the ones when the bass drum is playing. Cool. You can even create, I think you can create patterns of this. So if you want to change it every cycle, like this. So using the angle braces syntax, I'm changing the integer being evaluated every cycle. And so one cycle I'm getting this binary pattern, the next cycle I get 132's pattern, the next cycle I get 44's. 44's is 44 is the same as 0, 0, 1, 0, 0. Wait. 0, 0, 1, 0, 1, 1, 0, 0. You get the idea. So basically it's taking an integer, converting it to binary, and then turning that into a structure pattern. And this is really cool because it's a very fast way to create patterns without having to think about or type a lot, rather than type out all those bass drums and rests like this. Instead of doing that, you can just give it a number. I personally really like it when you just kind of give up control to TidalCycles and let it create a sequence for you, and you don't exactly know what it's going to do. And you've got a ton of numbers here. A ton. How many? Yeah, so I think it's a no, 28. Oh, what am I doing? True. I'm trying to figure out how many digits are available. 120. Yeah, so you basically have an 8-bit binary will produce an 8-bit pattern. So if you go above 255, if I do 256, I think it just turns all false then. It's an empty pattern. If I do 255, it'll do all ones or all trues. Yeah. All right, so binary will give you an 8-bit binary number to just allow you to make random sequences. It's amazing. Okay, then there's binaryN. binaryN will, let's look, I'm gonna look up the doc for this because I don't exactly remember. Let's go to TidalCycles.org. Hello? Oh, I think I need to not go full screen. There we go. So let's look up the docs for this. Hopefully this is interesting content. So we talked about binary. There's binaryN. Oh yeah, it lets you specify the number of bits for the pattern. So if you want a longer pattern than 8 bits, you can do binaryN 16, and it will change this to a 16-bit number. So binaryN 16 255 will give us, yeah, so it basically pads it so that it fills up the first 8 bits, which is, I forget, is it left endian or big endian, little endian? I don't remember. The pattern on the right side will be full, and then the first 8 slots will be empty. So but what this allows you to do is to make bigger numbers, bigger patterns. So the bigger the number, the more it'll fill up. Yeah. So here, a number like 10,000, you get quite a array of different steps. So now we've got a pattern of 16 steps. So you have basically a deterministic, insane sequencing machine. It's like you've got I don't know how many. What's the max int of 16 bits? Is it 64,000? No, it's more than that, isn't it? It doesn't matter. But you've got just this incredible number of sequences that you can just use with binaryN. If you want a 32-step pattern, you can do the same thing. Let's slow it down a little bit. So now I've got a 32-step pattern. I slowed it down so that it's not so dense, but now you can use really, really large numbers, and you'll get a ton of variation. So one thing you can do with struct is you can also invert the pattern. So if we do, let's make a function called Pat, which will generate a pattern for us. And then we can do struct Pat. So one nice thing about this is you can also invert the Pat. So if I had, oh, I don't know if my D2 is going to work today. Shoot. Sorry, I've got a weird audio routing setup. So I'm going to create a stack. So I'm going to put two patterns in a stack here because that's just what I have to do. So I've got bass drum, and then if I want another pattern, we'll do a clap. So now I've basically doubled up the sound, but with struct you can also do an inverse, which will swap the logic, so it will play the sample on all of the zeros or false steps. Getting a very not urgent phone call. Okay, so if I invert the clap, so it's playing on all of the zeros, basically, which is really fun. Let's maybe pick something that's not so... There we go. Put a hi-hat in there. So you've basically got, I love this because it's a very more kind of a computery kind of sequence. That's the nerdiest thing I've said all day. So you've got this very on-off binary type sequence. It sounds very computer generated, which I really like. And you're actually generating sequences with binary numbers, which is pretty cool. All right, so that's binaryN, which allows you to specify the number of steps. Then there's also another function called ascii. So we take bd struct. We can use a function called ascii and then give it a letter. And let's bring up the docs again here. ASCII will turn characters into 8-bit binary patterns using their ASCII encoding. So A will give this binary pattern. So if we do this, so ASCII will produce 8-step patterns. So if we change the letter every sequence, again, we have kind of a, now instead of numbers, we have kind of a text representation of our rhythm. And let's just make this a little faster for fun. So what I love about this is it's not random. It is playing the same sequence. In this case, it's going to repeat after 5 cycles. But it's kind of an odd rhythm, and it repeats every 5 cycles. And you don't have to really type much to get this. You can even talk with your audience. If you so choose. Yeah. Hold on one second here. Yeah, you could certainly pump data from some external source, and if you can convert it into an int to use in your patterns, you could certainly get data from somewhere else and bring it into your code. So I'm just reading on the chat here. Yeah, absolutely. You don't have to type it. You could get it from somewhere else. I am terrible at Haskell, so I don't know how to do any of that kind of fun stuff. I told myself I'd learn it like 6 years ago, but never did it. Anyway, so you've got binary, binaryN, ASCII, and they all do the same thing. They just produce binary patterns of, the only difference is that binaryN will allow you to specify the size, how many bits. And of course with this, you can also do the inverse as well. Inverse. There we go. So you've got kind of 3 ways for just instant rhythmic machine stuff. And this is equally as powerful as like the Euclidean sequencing too, which I've talked about in the past, I think. But just to kind of review that. So if we create a Euclid sequence for the 1 here, and we'll make it a 16-step thing. And then you can use the angle bracket once every cycle style syntax to change the number of steps it's trying to fill up every cycle. And then you can rotate it every cycle too. And here I think we have a sequence that will repeat every 20 cycles. We've got 4 step values that it's filling in 16 and 6 rotations. So 6 times 4 is 24. I think this will repeat every 24 cycles. So just like the Euclid stuff, I think the binary, binaryN, and ASCII are very fast ways to just quickly generate some fun stuff. I remember 5 years ago typing patterns like, this. Where I tried to explicitly define the rhythm all the time, and there's really no need to do that. You can if you want, but I think the binary stuff is a lot more interesting. Okay. Next thing I want to talk about a little bit is the at syntax, and by extension, the underscore syntax. So I assume the audio levels are okay. Nobody's saying anything. So let's do this. If we do BD. So with this sequence I just created, I'm playing the bass drum sample kind of in a Euclidean style syntax or rhythm, but I'm not actually typing it that way. I'm just typing the sample. Then the tilde is for when I want a rest or an empty event. So so in the background, Tidal is playing a sample, then resting, playing BD, then resting, then BD, then resting, and it repeats. Another way you can do this is with underscore instead of tildes. And it produces the same sounding pattern. The difference is that instead of adding an empty event, TidalCycles is instead extending the length of the previous event to fill up more space. So it has the same time duration, but it's not actually inserting an empty event. It's not really noticeable with BD, but if I take a longer sound, what's a longer sound? Is there one called pad? Yes. Okay. It's going to go for a while. Okay, so I've got a long sound called pad here, and then what this does is it sets the legato, or it sets the length of the sound to be played. So if we do this, oops, it will only play the pad sound for the length that it occupies with itself and with the underscores. No, I was wrong. I made a terrible mistake. I just gave you some bad information there. I was wrong. So it plays the sample for the entire length of the sample, but if you add a legato, it will then play it through the underscores as well. There we go. So you can hear when the pad sound starts again and when it's ending. If I take the same pattern and instead use the tildes, then you'll hear it get cut off at the empty event. It's very quiet. I'm not sure you can hear it very well. But the underscores allows the sound to play through the underscore parts of the event. Okay, why am I talking about all this? The at syntax is like a shorthand for the underscores. So let's get rid of this. So what I can do, instead of typing all those underscores, I can do pad at 3, pad at 3, pad at 2. It's the same thing as using underscores, except I'm using this at sign to say how many events the sound should occupy. Explain the legato function in comparison to the cut function. Yes, let's do that. So legato will, they do pretty much the same thing, except, let's go back to this example here. Legato only plays the sample for the length. I got to say this right. In the pattern, we are telling the pad sound to occupy 3 steps here. 3 steps, 3 steps, 2 steps. Legato 1 will make sure the pad fills exactly that many steps. If you use cut instead, so here's legato. If I change, and then if I hush, or if I stop the sound, the pad stops after it's occupied that many events. It's done. If I change this to cut, it sounds the same initially, but if I stop it, the pad sound will actually keep going. And that's because cut does not honor the length of events that a sample should occupy. It lets the sample play forever until the next sample is played. Then it cuts it. So legato will truncate a sample to play only in the number of events it should occupy. Cut will allow it to play forever until it's triggered again. It kind of sounds like I'm saying the same thing, but it's 2 totally different things. Where it becomes a little more evident is if you do pad legato, and then start changing the cycles per second. Pad will always occupy a full cycle no matter what the tempo is. So if you start messing with CPS now, I guess, again, you could use cut to do the same thing, but legato basically just sets the exact time that the sample is allowed to play in. Hopefully that helps. I don't think I explained that very well. It's like legato is like how long you're pressing on the key on a keyboard. You could think of it that way. And then when you let go, that's when legato is stopping. Oh, I forgot to say the cool part though. You can change the legato value. Instead of just 1, if you do like 0.5, it will only have the pad occupy half of the length that it normally would. And if you do 2, it'll be double the length. So now each pad will extend into the next cycle, and it'll be twice as long. So yeah, it's kind of like, instead of cutting stuff all the time, legato is kind of nice. It allows sounds to kind of breathe a little bit more within the space that they're given. And you can also do cool, I don't have a good sample to use at the moment. I'm getting a little bit off track, but maybe we can get back to that. But yeah, so legato is like how long you're pushing down the note on a keyboard. Think of it that way. All right, so back to the at syntax. It's also something that's fun to do, and we're definitely getting into weirdo mic sequencing territory. I like to use the at syntax in combination with the polymeter stuff. So if I do something like this, I don't even know what this is going to sound like. Basically just specifying a bunch of weird durations, and then giving it a cycle subdivision of 16. Let's put it's a little bit wonky sounding. All right, so what is going on here? I don't know. Tidal is just so weird sometimes. It's just amazing. Okay, so given the polymeter syntax, which allows you to cram as many events as you want inside of your string here, but it'll keep a subdivision of, in this case, 16. I could do 8, I could do 4, I could do any number really. So what I'm doing is I'm saying define a cycle or a sequence that is 3, 6, 11, 21, 28 steps, but keep a subdivision of 16 so that once I get to the 16th step, it'll wrap and start playing the 17th step in the sequence. And I've added this hi-hat here just to kind of, so you can feel the pulse a little bit. I don't know if you think this is really cool, but I do. It's like, so this pattern is the same as doing BD, actually it's this. 1, 2, 3, 4, 5, 6, 7, 8, 9, BD, 1, 2, 3, 4, 5, 6, there. So these two patterns are equivalent, and obviously the one with the at is a lot shorter. It's a lot easier to type than all these underscores. I'm a big fan of the polymeter stuff with the curly braces syntax. If you're not familiar with that, just let me know. We can talk about that a little bit. So yeah, it's like, yeah, non-random syncopation. That is exactly what this is. It's like kind of this flowing sequence that is not random. And then we could do sometimes could change it to a clap. Sometimes by that's terrible. So hopefully you get the idea. It's just another really fast way to create another type of sequence. If you find that you like this kind of sequence, but you don't like doing all the typing of the at and all that, I don't really have a solution for that. But if this is what you're going for, you just have to kind of go through it. Otherwise, like I was showing you with the binary stuff, I find that a little bit faster. So one other thing I could show, because this is going a lot faster than I thought it would. We're at about 30 minutes. How's everybody doing out there? All right, let's do some fmap stuff. This is another thing I've been doing recently, which is super fun. Kind of related. So fmap. So let's say I want to define a pattern of ones and zeros that define which, and if I want a bass drum to play on the ones and I want a clap to play on the zeros. How do I do that? So let's say I've got a pattern like this. Yay. So I want this to be the rhythm, but I want to have, or maybe I want a third number in here. So if I so let's say I want a bass drum on 0, clap on 1, and then a hi-hat on 2. This is no longer a binary pattern, so I can't use struct for this, and I can't use the inverse struct. What I really want is I want to map. I want to map these numbers to a sample. My Haskell is very weak, and I'm going to do a terrible job explaining this, but here it goes. So what you can do is use something called fmap, and then pass in kind of your map of 0, 1, and 2, what you want played. So I'll do bass drum, clap, hi-hat. You got to do 2 bangs after that, and I can't explain why. And then the pattern. Will this work? No. There we go. So the hi-hat's kind of hard to hear in there. We'll do ODX instead. So now I've created this map where I've got just a pattern of numbers and then what each number equates to. This pattern is also the structure of the rhythm. So if I do something like this, you can start at 3, add 3. I'm going to put the pattern actually in the things so it's easier to type. And I'm losing screen real estate. Sorry. Oh, can I? You know what we're going to do? We're going to hide our activity bar. I'll buy us a little bit of space. why am I updating that one? All right, let's try this again. So then I can change the numbers from, you know, between 0, 1, and 2 to change the sample that's being played. Or I can change the map. I think you can even put a rhythmic pattern in here too. So I can do BD times 2. No, you can't. There we go. Oh, I think if you do a index as a list, thank you. If I do an unwrap, I think then I can do the times 2. No. That doesn't really do what I want either. I forget what unwrap does. Oh, unwrap is important. If you want to use a rest, like the tilde, you have to use unwrap. So now the ones are a rest, a tilde. So I find this useful because if I have two different patterns, but I want them to have a different mapping for the same pattern. So let me put this back up here. And then, sorry, I can't use D2 today because my audio setup is weird. And now I have a set. Let's bring back the pad. We'll play the pad, but we will have it play only on step 2. No, then I would just need to do this pad and then set the legato. This is not as okay. I had a more complex example, but it's over MIDI. It's not with samples. And if you want to mix samples and MIDI where you can't really put everything in one map like this, you need a separate map. You can do that. I'm going to leave it at that. You can do that. Maybe I should show you the code. Want to see some code? I promise you'll hate it. This is something I've been working on. So yeah, I've got a bunch of different maps, and I've wrapped the fmap function in a custom function that I called wrapper. And then for my melodic synth, I've got a map on note. On my drum machine, I have the map to the MIDI channel, and then also on the melodic synth, I have a control change value mapping. This is what I'm trying to get across, but I'm not prepared to play this because it requires some goofy audio connections. So I've got this pattern with 0s, 1s, and 2s. I've got a melodic pattern that will play a note. Based on that mapping, I've got my drum machine that will play a drum pad based on that mapping, and then I have a MIDI control change value it's like a slider that's all the way on or off based on that mapping. So you get the idea. You kind of use these patterns as data and then just plop it in to any mapping, and then you can kind of reuse that stuff. I wish I could show this in a better demo. Anyway, hopefully that helps. Is there a better Latibro? Is it Latibro? get the idea. These are building blocks of stuff to allow you to do some fun things. I'm going to backtrack a little bit and talk a little bit more about legato. I'm seeing the bit rate on my video go down. I think somebody else in the house is watching videos online or something. I think they call that streaming. All right, so let's say we've got stack, we'll do BD, and then we'll do, we'll do Latibro. And then we're going to use the plywidth function that will repeat the note. Let's get rid of the stack so you can understand this. So I did a video on plywidth a while back. What this code's going to do is it's going to repeat the Latibro sample 10 times within the span of one cycle. And I set legato equal to 1 so that each hit only occupies 1/10 of a cycle. But then what you can do with plywidth is the second argument. Right now I've got it set to ID, which will just do nothing. It just plays the note again. But you can put a function in here. I could do like speed 2. So every repeated note is higher pitched. Or where legato comes in is I could multiply legato by some factor. So if I want the legato to decrease on every played note, I could do this pipe bang legato 0.9, which will multiply it'll calculate the next legato value by taking the previous legato value and multiplying it by 0.9. I'll shorten it up a little bit. Increase the number of repeats. So kind of circling back to legato, it's a way of controlling how long like that note on a keyboard is pressed down. You can't do this with cut. Cut will just allow the note to play right into the next one. So this is a way of controlling note length. Give legato a list. Yes. Let's do that. So let's get rid of this crazy code. So if you give legato a list, yeah, so I think what's happening is the first half of the cycle is normal legato length, and then the second half of the cycle, they're all multiplied by 2. So you get a whole bunch of different values here. Yeah, and you can just change it every cycle. So one thing with plywidth is that if you separate a pattern with comma, which normally means you're going to stack 2 different rhythms on top of each other, plywidth actually interprets that to result in like an arpeggio, where it'll play the first value, and then the second value. You get the idea. That's pretty much all I wanted to talk about today. I'm not really prepared to talk about anything else. What else could I show you? I don't know. Maybe I'll just play around for a little bit. If you got any questions, leave a comment in the chat. And yeah, jam time. Let's jam. Leave a comment in the chat, and maybe I can answer some questions. Let me pop out the chat here. I can't read it very well. Got old man eyes. Okay, so what are we going to do? I've got the default dirt samples loaded up, but I've got all kinds of other stuff too. So I suppose to make this like a learning experience, I should jam on the things that I just covered. But whatever. You could make easy tuplets. Tuplets. 1 at 7. Oh yeah. Like stuff in 7. Absolutely. That's all you need to do. Yeah, so this is basically playing a bass drum for 7 steps, but with a 16-note subdivision. So yeah, it's just playing in 7 right now, 7 over 16. That's all it's doing. Yeah, easy as that. Let's start here, shall we? Yes. Am I typing something wrong? Why isn't it? There we go. I'm gonna break out the custom functions here. All right. That was fun. All right, I'm going to wrap it up. Thanks for tuning in. I hope to do this a little more often, get back into the groove of things. streaming, Tidal stuff. Yeah, okay. So enjoy the rest of your Thursday. Stay safe out there. It's a long Minnesota goodbye right now. That's what this is. All right, so take it easy. I'll see you in the future, if not later. Have a good one.